And we're here for day 4 of coding Leetcode algorithms in JavaScript. Sorry it's been a few days, and apologies for the quality of my audio. Last time we were on, I think I just had a loose USB connection or maybe just a bad connection. And I think after I made some adjustments and I kind of tweaked, we ended up getting a much better audio quality. So if my audio doesn't sound as good, just let me know today, but I'm hoping that I've resolved the kind of intermittent crackling issues we had. So today we're going to continue through algorithms 1 in Leetcode. So we're a few days behind, so we might end up having to recycle this eventually because, as you can see, Leetcode doesn't care about you taking breaks, so it continues to cycle through problems. So we might have to restart the program again if we don't get to in the next few days, but we'll get through all these problems together. No problems at all. All right. Without much more ado, I think let's go ahead and get started. And today we're going to start with 189 rotate array. So like we always do, let's go ahead and start. Let's get this set up better for all of us, I think. Let me go ahead and make the font a little bigger here. Perfect. All right, let's read the problem. And everyone will note this is our first medium problem we've worked, so hopefully we're able to figure it out today. All right, problem statement. Given an array, rotate the array to the right by k steps where k is non-negative. So this is almost analogous if you've ever done anything electrical engineering, or really any sort of semiconductor kind of application where you have something called a shift register, where you want to push things left and right, or even like a rotary register in this case, because they come back to the beginning. It's kind of like that, but in software. But the general idea is that we're going to give some amount of shifts, k, and the idea is that in the most optimal way possible, we want to return the array shifted with all the numbers shifted that amount. So let's look at an example so we're kind of clear what's going on here. So given a list of numbers 1, 2, 3, 4, 5, 6, 7 with a rotation number of 3, we see that we get now 5, 6, 7, 1, 2, 3, 4. And that makes sense because the number 5 will rotate 1, 2, 3. So number 5 becomes the 0th index. 6 goes 1, 2, 3, becomes the first index. And then 7, for example, would go 1, 2, 3, becoming the second index. So pretty straightforward conceptually. Now let's look at example 2. The list in this case is -1, -100, 3, 99 with a shift of 2. And what we see is that even though we have some negative numbers, which I'm sure we'll see in the constraints is valid in a moment, what we see is that the order is like we just previously described. So 3 will shift 1, 2 to the start of the list. 99 will shift 2 to the second in the list at index 1, and so on and so forth. So pretty straightforward problem. Implementation might take us some places, but like I said, I think I have a rough idea of how we can do this problem. It's going to be a little bit unorthodox. But before we get too far into pseudocode, let's finish by reading our constraints. So constraints in this case is the length of the list is between 1 to 10 to the 5th. So again, no issues with overflows. It's a pretty reasonable range of lengths. Numbers can be anywhere between -2 to the 31 or 2 to 31 minus 1. That is the safe range in JavaScript. So again, no overflows. And k, the number of rotations, can be 10 to the 5th. That's a lot of rotations. And there's actually a trick, if you think about it intuitively in a second. But what if I told you that actually the number of rotations doesn't have to be that many? And in fact, what will end up happening is that we're going to end up subdividing this to effectively normalize it to a lower number of rotations. That's probably a terrible way to explain it, but the idea is instead of rotating it 10 to the 5th, you can actually divide that number by the length of the list until you get what's called the remainder quotient, if you remember the percentage sign in programming or maybe even in a logic class you've taken in the past. And that number of rotations after you've rotated through the list that many times is the actual true number of rotations you need. That'll make more sense in a second intuitively once I show it, but I'm just trying to kind of seed some thoughts here as we kind of get ready to step into the pseudocode of how we think the algorithm will be programmed. All right, let me take one sip and then we'll begin. All right, so there's a couple of ways you can do this problem. And this is generally me going off memory because at one point I did work this problem. So you can do the absolute naive approach. So and I think I haven't described this in a stream yet, but when I say naive, what I mean is pretty much the worst performing or most straightforward method of rotating this list. So intuitively, if you gave, like, if you knew nothing about algorithms and you gave yourself this, like, how would you do this? Well, it's pretty straightforward, right? So you would go for each, so you would do something like, you would create a new array, right? So you create a new array, and then what you would do is you would go for each number, so basically for each number in the list, you would figure out intuitively, okay, it needs to go to this place. So you would basically iterate through each number, say, okay, this has to rotate k times, in this case, right, it has to move a certain number of ways, and you would keep rotating it over and over and over and over again until it gets to the next spot. And then you would basically do that for the length of the list, and then you would return the list, the new list in this case. Now that is okay if your list is small, right? Let's think from an O of n perspective. You know, rotating 5 numbers, that's really no big deal, right? Like from a computational perspective, that's pretty low. But if you start getting up to some of the list lengths you're seeing, like 2 to the 31, you're going to run out of memory. There's just, or I should say, you won't run out of memory. Memory is not the problem in this case. You're just going to be waiting a while. Because 2 to the 31 is an absolute large number of operations to have your computer try to do, especially if you're doing, you know, thousands, millions, tens of millions of operations at a time. So the naive approach falls apart with sufficient length nums. So we're going to throw that away. The other naive approach we took here, and this is now going to talk about the little shortcut that I believe is what we're going to have to do here with the length. It's very naive to just keep rotating the number around and around, because at the end of the day, what happens when you rotate it around the list? So let's conceptualize this, because I'm a visual person, and I'm sure the one person on here, you may be a visual person too. So suppose I have a list that is, let's make it simple, 3 numbers, right? Let's say 1, 2, 3, and we have to rotate this. We have to rotate the list 6 times. So what is this list going to look like? So it's going to become 3, 1, 2, then it's going to become 2, 3, 1, then it's going to become 1, 2, 3, then it's going to become 2, my gosh, sorry, this this breaks my brain, 3, 1, 2, and then it's going to become 2, 3, 1, right? So that's 5 iterations, and then the final iteration, what do we get? We're going to get 1, 2, 3. So this was the original list right here, 1, 2, 3, right? And after 6 rotations, what was the net result we got? Well, the net result we got was actually the original list. By the way, I didn't mean for that to happen. That was completely a coincidence. But I think the point holds is we rotated 6 times, and what happened? We got the same list back. So what does that intuitively tell us? Well, what is kind of the key? What did we discover as we went through this? Well, what we discovered was that if you rotate the list by the length of the list, so in this case 3, so every time you rotate 3 times, you get back the original list. So if you rotate a list by its length number of times, you will start by scratch. So why would you need to do this? There's no reason to do it, because from an architecture or like an algorithmic perspective, you're right back where you started. Like if you think about the old joke from high school, if you drive to work and come back, you've done no work. That's literally what's happened here. We've come back to the original result we had. So a trick to dramatically optimize this problem is, let's say k is equal to 6 in this case. Well, what we can actually do is we can divide k, which is 6, by the length, and I think this is correct, and we're going to have to do some testing because it's literally been months since I last did this problem. What I'm thinking we can do here is we can divide k by the length of the list. And at least if we divide it by the length of the list, and I think in this case it's going to be the length of the list plus 1. No, I think it's length of the list. So in this case, if the list is 3, then k is going to be basically 2 rotations. So is that going to work actually? Let's think about this. Let's intuit this a second. What I can't remember right now is whether it's actually the length of the list we're trying to divide by here, or, well, let's just grok this. Let's just kind of think through this for a second. So if we have to rotate it 6 times, the length is 3, right? So 6 divided by 3 is 2. If we only rotate the list twice, we're going to get 3, 1, 2, then 2, 3, 1. Okay, so I'm trying to remember the trick to this problem. Might have to come back to it. I was very confident, but now I'm struggling. Maybe someone in the chat can help me kind of tell me if I'm, I'm too far off or not. And I notice I'm a little hot right now, so let me see if I can kind of turn myself down a little bit. 1 second. All right, testing. That seems a little bit better. At least I'm a little bit not blowing it out as much. Okay. So let's sit on that, but I do think that we are supposed to reduce that number of rotations by the length of the list somehow. So we'll think about it a bit, but let's kind of keep going for now. So let's go ahead and rotate our list. So we've discussed the naive solution, and we've also discussed kind of a way we could potentially reduce the number of rotations we have to do. So what is the clever trick to this problem that actually dramatically reduces the time complexity? And it's a little surprising. I didn't get it the first time I did it, but it actually involves reversing the list a few times. And kind of let me explain how this works. So say, for example, your list is 1, 2, 3, 4, 5, 6. I believe the way this works, and this is kind of a cool trick. So let's say you're supposed to rotate it. Let's say in this case, you rotate it 3 times. So if we were to rotate this list 3 times, then what we're going to end up getting is 4, 5, 6, 1, 2, 3, right? So we've rotated through 3 times. 4, 5, 6 comes to the front of the list, and 1, 2, 3 falls to the back. So a cute little trick we can do here is, instead of naively going through each number and then figuring out what the final answer is, the cute little trick is actually to come to the index. So let's erase this. So let's put this down at the bottom. This is going to be the original solution. So we're going to put this way down here. So the cute little trick you can do is take the front end of the list. So in this case, 1, 2, 3, and reverse the front end of the list. Sorry, I'm trying to remember exactly how this works. So I believe it's 3, 2, 1. And then what we want to do is we want to, let's see if I can remember how this worked. And then we want to reverse the back half of the list. So in this case, 4, 5, 6. So 4, 5, 6 then becomes 6, 5, 4. And there is an actual algorithm through this. And to be honest, we're going to have to look it up together because I've forgotten it. But there is an actual mathematical proof that is behind this, and we'll look at it in the solution in a bit, kind of see how it worked. But essentially, you get this. So this is still wrong, right? Now, the real magic is, if you look at this backwards, you'll see that if we read the list backwards, it's 4, 5, 6, 1, 2, 3. Well, what is the relation of this to this? It's reversed, isn't it? Because if I reverse this, it becomes 4, 5, 6, 1, 2, 3, which is the answer. Magic, huh? I'm going to do my magic hands here. But if essentially we just committed magic. So remember how we were discussing about reducing the number of rotations? We're still going to need that in a moment, but at least for the naive lower solutions, essentially we take this number, as long as it is less than the length of the list, and we perform 3 reverses, and we're actually able to get the answer. And in fact, this is the optimal solution to the algorithm. So I haven't proven it to you, the math. To be honest, I have not fully grokked the math on this one. But again, I'm sure if we do this problem, Pramp. Can you tell me what Pramp is? Sure, Chris. Can you tell me a little bit more about it? So that's actually something I've talked about. So I'm actually not actively interviewing. This is, me just trying to get a little better at kind of learning algorithms and kind of being able to explain technical concepts. But, I think once I get to a point where I'm actually comfortable with my explanations and I can actually tell you, I'm not looking to do asymptotic analysis or anything. We're not going that hardcore. There are plenty of people like MIT and stuff who've done a way better job of explaining that kind of stuff. But I think from a more, how do I say it? A more practical explanation. I know that sounds bad, but that's the best thing I can think of. Just being able to intuitively explain it without having to get too big into the proofs. That's kind of where I want to get, because I think it helps me overall be able to explain other things as well. So, I'll take a look at that. Thank you so much for suggesting that. I appreciate that. So, all right. So back to kind of where we were. So we basically figured out if we reverse both sides of the list in half. Oh, okay. I gotcha. Okay, yeah, I'll definitely take a look at it. Thanks so much for suggesting it. So if we split the list in half and then we reverse it, we actually get the answer. So Before we do the optimization to figure out how to reduce k to figure out, okay, how many rotations we can eliminate, let's go ahead and code just the case where k is going to be less than the linked list. So let's go ahead and get started. Now, we could save some space by doing this in place. I'm not going to do that today. Let's just start with a fresh array. Let's kind of go the immutable approach. And if you're not familiar with immutable, what immutable basically means is you don't destroy the original data. You basically make a copy of the data and you work with it. This is a very, very, very popular thing in JavaScript and has been so for years. You might have run into libraries if you're familiar with JavaScript like immer.js, which is the backbone of a lot of other frameworks such as, wow, I almost forgot Redux. Shame on me. It's kind of the backbone of Redux. Like a lot of the actions, like your actions you form, like that's all built on Immer. That's kind of where you get some of the, that's how you make sure your actions and things are pure and you're not accidentally destroying your stateful data. But like even generally in React and like other JavaScript frameworks that have come out in the past 10 years, most of them operate on the concept of immutability, and even JavaScript kind of heavily moved to immutability with ES6, and that's where you got your map functions and whatnot, which essentially take a set of data, perform operations, and return a copy of that data with some modification. Okay, I got you. And that might not be a bad idea, Chris, because honestly, I really appreciate feedback and like I learned from others. Like, pro tip for anyone who's watching the stream now or later, the best thing you can do to become a better developer, in my opinion, is shut up and listen to other people every once in a while. Because it turns out you haven't run into every problem that exists. So getting the opinions of others is good. Now, that doesn't necessarily mean you have to take their opinion. But you can listen to it and then think about it and then either make a paradigm shift for yourself or maybe even try something you've never done before. But just, kind of, putting your hands together, arms together like this and saying, oh no, this is the only way to do something. Like that's a good way to get left behind and basically not end up making the optimal solution for your customers, and it kind of stagnates your growth. So it's always good to kind of keep an open mind, more or less. At least that's been my experience as both a semiconductor engineer when I originally graduated college, and also as I've transitioned into more front-end development. All right, but sorry, I went on a tangent. I apologize. I'll try to stay focused here. So again, we basically discussed the cool way to do this, and again, we'll look at the actual name of the algorithm in a second. Is you basically divide the list where you basically find the point k in the list where you're at. You rotate both sides, and then you rotate the entire list, and the resultant is the correct answer. So let's code that initial case. So I'm going to erase my whiteboard here, and let's just define a new array. So naming is hard, right? The two hard things in programming are naming things and off by ones. And as you've seen in some of the videos so far, I definitely am guilty of some off by ones, but it's tricky sometimes, especially if you haven't been doing algorithms recently. Like you really have to kind of get in the state of mind, especially given a lot of times in front end, you're not like creating your own sort algorithms. You're not doing Dijkstra. You're not doing any of that stuff, right? Like at the end of the day, you're probably creating forms. You're probably styling pages, and you might be fetching data from a backend and rendering it, but you're certainly not doing anything complicated. And in fact, a lot of that more complicated logic ends up probably happening in the backend where it can be amortized. Or in other words, you do something once and then you send out a cached copy. And the net benefit is that the cost of that is divided by the number of times it's queried over a time period. We could talk about caching another time. Maybe I'll do a little discussion about, like how to kind of optimize your backend and front end together with a lot of new technologies that have come, like such as CDN caching through like HTTP response caches, and kind of like, general backend GraphQL caching. So a lot of the stuff, I don't know if you guys have heard about Remix, but Remix is server heavy, and there's a lot of advantage to basically caching your server-side render and making it kind of agnostic of the user's credentials, and then essentially coming in and then doing what's called partial hydration, which is you basically then update the state of the page after its initial render with data that might rely on live things like user credentials or like live data from a map or something. So there's a little bit of kind of two-part optimization you can make, but that's out of the scope of this, so we'll get back to the problem. But it's actually pretty fascinating, and you can kind of do some really cool things with the latest CDN technology. All right, so we have a new array. So what we're going to do now is we're going to go through, we're basically going to take that list of nums and we're going to basically split it at the point k, so from index 0 to k, so we can grab that range, and we're going to reverse it, and then we're going to take, actually, you know what, we can, all right, I'm going to do it this way. It's going to look a little scary, but it works. So I'm going to use something called array spread, which is kind of a newish thing. I mean, it's not really that new, but it's something in JavaScript you can do. And I'll kind of show you how to do this in two parts. So let's do it in this end. So the start of the array, so basically the new front of the array is going to be nums.slice. Now, slice is an array method in JavaScript that basically allows you to return a portion of a list. And I believe this is the immutable version. So let's check. I don't want to say something wrong. So my favorite resource to check JavaScript stuff is, of course, MDN. Oh, that was not what I wanted. I want Mozilla MDN. Boy, CentOS, that sucks. MDN's pretty ubiquitous. All right, so we're going to go to array prototype.slice. We're going to come in, and so you see the slice method returns a shallow copy of a portion of an array into a new array object selected from start to end, where end is not included. That's important. That means it's not inclusive. It's exclusive of the final value in the array slice. So that means if you want index k, you actually have to go to k plus 1 so that you're inclusive of k. All right, so let's go back to our rotate array problem now that we know slice is correct. So we want to start it now. Actually, theoretically, you don't have to put 0 because we're at the start of the list, but just so we can kind of understand what's going on here, I'm going to say we're starting at array 0. And we want to go to k plus 1. And it's not star array. I wish I could get a star. It's start array. And then what we're going to do to that, so we're going to get the first half of it, and then we're going to reverse this. Now, let's say, for example, you actually are in an interview. They might ask you to implement reverse and maybe implement slice as well. That's no big deal. You can basically do this with a for each or even a map. Or even actually in this case, you could even do it with a reducer. But at the end of the day, let's just stay high level here. Let's use the APIs that are available. And in this case, what we're doing is we make a copy of the data and then we reverse it. Conversely, the second step is we're going to define a variable called endArray. So we're going to take the list again, and we're going to slice it once more because we want to get a shallow copy of the data. But this time, we're going to start at, I believe, so it starts at it, right? So in this case, we want to start at k plus 1 because we don't want to copy the last number we got of it, and then we want to go to the end of the list. So how do we get the index of the end of a list? Well, as we discussed last time, it's going to be nums.length minus 1. And the reason why we do minus 1 is that the length is, so the reason why it's minus 1 is that lists or arrays in JavaScript are 0 indexed, so we have to subtract 1 off the length because we don't start with the number 1, we start with the number 0. So this basically offsets us backwards by 1, which is exactly what we're looking for. All right, cool. So we got the start array and the end array. So before we go any further, this is, and I think this is okay to do. Normally you'd whiteboard this, but we're in the console here in the IDE. We can do this. Let's just go ahead and console the start array and end array and make sure that we've actually copied and see, I almost made a mistake. This also needs to be reversed. So let's make sure that the data is as expected. So we're going to pull up this run code dialog. Now it's going to fail, right? Because we're not returning anything. But what we want to see is from our STIN. So see, I'm off by 1. So this is why it's important to check. So let's go see. This should be, so, oh, this is 4, 5, 6, 7. Okay, so we see we have a few problems here. Oh, and I already made a mistake. Do y'all see the mistake I made? I made 2 mistakes in this case. The first mistake is I just completely forgot what I read on array.slice, right? It creates a shallow copy of a portion of the array into a new object selected from start to end not included. The end is not included. So if I use the last index, guess what? It doesn't include the last index. So the first mistake I made is that we actually need to do nums.length. This isn't a problem. We're not going out of bounds. What this is basically just telling JavaScript is we want the whole thing. We want the whole back end of that list. So give us the whole back end of the list. So we're going to run it again just to prove that, yes, now we have it. And actually now it is correct. And the reason why, in this case, they are 4 and 3 is because it's an odd length. So of course, one of the arrays is going to have to be longer than the other. Now, that being said, No. Yeah, I mean, so okay. Thank you for that. I really appreciate that. Um, just to back up, and this is something I've said in other streams, but I'll go ahead and said it. This is not meant to be a highly scripted. I have the solution written down on a piece of paper, and I'm going to give it to you verbatim. Like I kind of find those boring personally. Like what I'm more interested in is kind of showing the process I go through as I approach an algorithm, and then based off that, including mistakes, because the only way I think you learn as a developer, and even just in general learning in life, wow, this is going to be so boxy. I apologize. The only way you learn is it's okay. It's not even about Leetcode, by the way. I think this is just about us learning to, learn some logic and kind of have some fun with some puzzles today, right? I think that's kind of the thing to think through. But moral of the story is like you don't learn unless you make mistakes. A person who makes no mistakes doesn't know very much, in my opinion, because they haven't gotten the experience of knowing they were wrong and that feeling of gratification of I didn't know something, but now I know it. So I'm going to be very upfront with you. I'm going to make a lot of mistakes. I'm going to try to figure out what I did wrong, and then we're going to figure it out together, like what it was supposed to be. Sometimes, though, I'm going to get stuck, and we're going to have to go to the discussion tab and look at a solution, but that's okay. And when that happens, what we'll do is we'll rotate back to the problem a day or two later and see if we can solve it without looking at the solution again. With the idea that eventually we can do tons of algorithms and go, oh yeah, that's Dijkstra's, or that's two-pointer, or that's binary search. So we'll know the strategies. It won't matter what the problem is. We'll recognize a pattern of what we're supposed to apply. Actually, no, I'm not looking to interview. This is me just practicing to become a better developer. I've always wanted to so let me back up. My background is actually in electrical engineering. I used to be a semiconductor test engineer for like 7 years, and then I got really bored of it. So I switched to front-end development. So I don't have a traditional computer science background. So right now I'm basically trying to retrofit kind of a more CS knowledge into my experience after being a front-end developer for 3 years. Oh, yeah, so my background is I have a master's in electrical engineering and I have a bachelor's in both double E and applied mathematics. So I do have some math background actually. And one of the hopes for this stream is that we might actually get into a little data science, because one of my favorite subjects in school was linear algebra, and you have to do a lot of linear algebra in data science. So we might actually do that. If you stick with me for the next couple of months, we'll probably get there a little bit. So, hey, this is between us on this stream, which is going to technically be public after. Nice. That's awesome. That's really great. I know a lot of developers who don't have a technical background, and they've all done great. So you're awesome. Like, anyone can program. I really believe programming's for anyone. So honestly, some of the best developers I know don't have backgrounds at all. Like, they're all self-taught. So like, kudos to you. Absolutely. But yeah, so moral of the story is like, yeah, we're going to do a bunch of things. Yeah. Awesome. So we're going to do a lot of things. We're going to learn together. We're going to make mistakes. If that makes me look dumb, that's okay. I'm not interested in looking perfect or, like one of those Twitter influencers that like post these long lists of things you should read. My goal is to just show like practically how to go through algorithms and maybe even code a game in Unity later. So we'll just have fun together here. All right, so we've got the list, back to the list. So you see that we're probably on the right track. It looks like we split it right. Now, the one thing that we have to consider here in an odd case is whether when we do the final reverse, whether the order is actually correct. My spidey sense is tingling that we actually have to bias it a certain way if it's an odd number versus an even number to make sure that we're not off by one on the reverse. But we might have gotten lucky and did it right the first time. So we'll find out in a second whether we were right or not. So now we've got the start and the end of the list. And so we've got our start and end. So we don't need this. Let's just leave it here. It's kind of good to keep debug stuff anyways. And so the final step we're going to do is we're going to do a return. So I'm going to do something that looks scary. Now this, by the way, this is highly wasteful what I've done so far from a memory perspective. And let me finish the problem, then I'll explain to you why it's very wasteful. And there are better ways to do it. But I think for today, just sticking to immutability is probably okay for today. And then we can start talking about how to save space as well. And maybe if we come back to this problem again and do it one more time. So at this point, what I want to do is I want to create a new array. I'm going to spread in the start, and then I'm going to spread in the end, and then I'm going to reverse that. All right, so let's talk about what this line of code does. So this is a new array. So spread syntax, what it does is it says take an array, break it up into its pieces, and then and basically push them into the stack. So for example, if start array is 5, 6, 7, the spread turns it back from an array 5, 6, 7 into a list of numbers 5, 6, 7, and then it pushes each of those into the array. Similarly, in this comma, and then I do end array, it'll do the same thing for the second set of numbers, which I think in this case was 1, 2, 3, 4, and it will put it back in the array. Now with spread, depending on the order in which you spread it into these arrays, you can actually kind of bias the order. So in this case, in this case right now, we have 5, 6, 7, comma, 1, 2, 3, 4. So that's what we wanted. We've created a new copy. I haven't modified the end array. I haven't modified the start array. So we'll talk about this in a second. But basically, we've made another copy of the data by doing this. And then we reverse it. So we had what did we have? We had 5, 6, 7, 1, 2, 3, 4. And now after that, we have 4, 3, 2, 1, 7, 6, 5. All right, so let's look at the test case again, because I can't remember what the rotation was in this case. So I need to get that information. So the rotation was 3. So if we rotate the original one, so this is what we think the answer is. So the original was 1, 2, 3, 4, 5, 6, 7. If we rotate it 3 times, what do we get? We are supposed to get 5, 6, 7, 1, 2, 3, 4. So up here we were 5, 6, 7, 1, 2, 3, 4. Did I do this right? Let's think about this a second. So if I reverse this, I got 4, 3, 2, 1, 7, 6, 5. So what did I do wrong? What did we do wrong, everyone? Let's think about this. So this might have to do with setting the index at the top. Yeah, you could definitely use a set to dedupe an array. That's not what we're doing here. What we're trying to do is we're actually trying to create a new array of all the numbers to synthesize it from the 2 subarrays, so then we can kind of consolidate the final list. But yes, sets are an excellent way to dedupe arrays, because you can, I think what you're trying to say is you can do something like this. If you wanted to dedupe the array, for example, you could do some syntax like this, right? Something like this, right? That's what you're thinking, right? So this will create a new array of unique numbers from an array. Yep, I've actually used this in production code before several times. Yeah, it's great, and even maps are great, because JavaScript maps are awesome because they are insertion order aware, or in other words, they keep the order in which they're inserted, which for objects, for the longest time, you can't guarantee the order that key value pairs are put in an object. I actually think that's changed now in a lot of engines. I think, like, for example, Chrome maintains its insertion order in objects now, but it's not necessarily a guaranteed thing. Only JavaScript maps guarantee insertion order, if I remember correctly. All right, anyways, long story short, no, I'm not. I've just been doing this a couple of years. I'm not smart. I am average. I'm here because I'm trying to get better. So don't ever feel like you're bad or anything. Why do you feel bad? I mean, you're here. You could be watching a show, but instead you're here watching me try to stumble through this algorithm, right? So you're trying to get better. So that's good. All right. So let's step back and think through the problem. So we reversed. Okay. So oh wait, I'm so dumb. Okay, so it's not this, right? So okay, let's start over. I think we were trying to get too cute here. So the original number is 1, 2, 3, 4, 5, 6, 7, right? And then we reversed it, so it's going to be 4, 3, and we reversed it up to k plus 1. So that means 0. So k is 3, so that's 0, 1, 2, 3. So yeah, so we reversed it up to 4 numbers, and then this became 7, 6, 5. So this is the state of the array up to this point right here. And then what we wanted to do was reverse it. So it became, let's see, 5, 6, 7, 1, 2, 3, 4. And the answer we expect, if we run this code real quick, is we expected... That doesn't make sense. That's not the output I expect. It's saying that I didn't even reverse the list at all, but from looking at the pseudocode I gave here, it would seem like it should have rotated, right? Because I came to the same answer after I did this. So, oh, you know what? It's probably so silly. So I probably have a syntax error right now, and it's just bugging out a little bit. Let me remove my pseudocode real quick, and let's try to run it again. Okay, so let's figure out what's going on here. Let's try to understand why we are not getting the result we expect. So let's break it down into pieces, okay? So let's see whether our new array is actually the correct value. So we're gonna grab, we could do breakpoints, but let's just do a console log so we can kind of see step by step what the values end up being. So the new array is 4321765. Well, that looks correct, right? That is supposed to be what the array is before it's reversed. So that would actually seem correct. So does anyone know what obvious mistake I've made here? It should return the reversed array, which is going to return it reversed, but it's telling me that it's not reversed. So what have I done wrong? Do I have an early return anywhere? No, I don't think so. All right, well, let's see what happens when I do reverse here. So let's go ahead and reverse it inside the console log so we get a full simulation of what's going on here. Yeah, that's the correct answer. So what is going on? So if you look here, the new array is 5671234. The expected is 5671234. That is, these are the ones that frustrate me the most, y'all, where I clearly have the right answer, but I've done something really, really dumb, and I'm not returning that. Oh, shame on me. Shame on me. So if you're new to JavaScript, this is a comment block. You probably know that, but this is more what we call JS doc style commenting. And the idea is if you're using something like Visual Studio Code or whatnot, when you hover over these and you get IntelliSense, which is kind of augmenting the code to kind of give you more contextual information, either from a library maintainer who writes the code or even yourself to remind yourself in 6 months what the heck you just wrote. It gives you hints. So what does it say right here? Return void. Do not return anything, modify nums in place. Everything we've done in this problem so far is not modifying it in place. In fact, what we've done is we've created a bunch of data, then returned it. This won't work because the grader is expecting the function to return nothing. So long story short, this is the correct solution, but instead of getting new data, we actually have to do it in a way that it's using the same data structure, in this case, the list. So let's take a drink here, and then let's think how we can now rewrite this to be in place. This is the non-in place solution. This is the one that basically allocates a new array, right? In this case, 1, 2, 3, 4 new, well, three new arrays. So this is like 3n in terms of space complexity. And it's not n squared because it's n and then n, then n. So it's 3n, which in big O is going to be just O of n, because for a large enough length of the list, the constant in front is meaningless because a constant doesn't grow fast as infinity, which is what big O scales do. So sip real quick, and then let's figure out how to do this in place. All right. So I think the way to do this in place, and let's go ahead and save this code for now. So I'm going to comment it out just so we have it for reference here. The way to do this in place is to use that other utility I was actually referring to, which is array, but it's not slice, it's array.splice. And by the way, these array methods, I'm going to be honest, I confuse splice and slice all the time. And I swear to goodness, I have to end up going back and looking at what I did many, many, many times. All right. So what splice does versus slice, which made a shallow copy, is splice changes the contents of an array by removing or replacing the existing elements and or adding new elements in place. Sound familiar? Again,